Okay. And quotient identities, quotient means something divided, right? So we have tangent is what? Sine x over cosine x. Cotangent is cosine x over sine x, right? So what are we doing with these? Is anyone in here in a sport? Mia, what do you play? Okay, and what position? So if you got hurt and you couldn't play, would they cancel the game? What would happen? And who do they have? Do you know who would play for you? Or can you give me one person? But they wouldn't cancel the game. Someone else would go play for you. Okay, that's what this unit is about. So if you need to get 1 over cosecant out, sine can go in and substitute for him. If you need tangent to go out, you could either substitute 1 over cotangent, or you could substitute sine over cosine. It's all about substituting. These are identities. And what we do is we try to take something complicated and make it easier so we can handle it. And we do that by subbing in someone who plays for them. And I also want to point out that all of these work if something's squared. Like if I had tangent squared x, that would be 1 over cotangent squared x. Okay, so you could do the same thing if it was squared or cubed or whatever. These ratios, they're just ratios, right? So now I need you to memorize 9 equations. Now that's kind of scary. I can get it down to 3, right? And they're really easy. So let's look at, we're going to build these equations we need, and we're going to see what happens. So what is the Pythagorean theorem? There we go. That's what we're going to do. Right? This is very familiar to you. You've been doing that your whole life, or at least since you can remember. We're going to do that over here, except you all know that the x, remember our point xy, x is cosine, sine is y. So what is our Pythagorean theorem going to look like here? Sine squared x, right? That's a squared plus b squared cosine x equals c squared, which is 1 squared. Does everybody see where this came from? Because we're going to take this one formula and turn it into 9 formulas. But this is where it came from. And this one is kind of easy to remember, right? So I don't need to write 1 squared. So sine squared plus, whoops, x. Let me make that nice and neat and not. So sine squared x plus cosine squared x equal 1. We have to memorize that. This whole page is like a brain. When we're done with it, we're going to start a new brain for this unit. You have 2 paper brains going on now, right? You have that one with the whole unit circle, and then you have one with the trig graphing. We're going to add one to it. And that's not bad, right? Instead of a notebook 3 inches thick, you have 3 sheets of paper because we whittle it down as we go. Now, if I gave you this formula, could you get sine by itself? Yes, what would you do? Subtract it, right? Subtract cosine. So would you guys agree that sine squared x equals 1 minus cosine squared x? And could I do the same thing and get cosine by itself? So I only knew 1 formula and now I have 3. That wasn't so bad. Based on what I've told you so far about subbing in the game, can anyone tell me why I want to get sine and cosine by themselves? Anybody at home want to do it? Well, we're going to sub, right? if sine squared x is supposed to play in the game tonight and he gets hurt, 1 minus cosine squared x can go in subform, right? Or if 1 minus sine squared didn't turn his homework in, so he can't play in the game, I'm going to sub cosine squared in. Does that make sense what we're going to be doing with these? We're going to be continually subbing them in. Okay, let's build some more. So I'm going to write, now there's 3 formulas, and I'm going to build 6 more out of this very formula up here. So let me switch colors here. So we'll go sine squared x plus cos. It's really important for your brain to see where these came from so you can recreate them someday. Now, what are we going to divide by? Cosine squared x. So that's cosine squared x, cosine squared x, cosine squared x. What does that turn into? What is sine squared x over cosine squared x? You have it written up right up here. What is it? Tangent squared x. What is cosine squared x divided by cosine squared x? What's 1 over cosine squared x? Secant squared x. Aha, we have a new formula. Now right here, I basically have secant by itself, right? So we've got secant squared x equals tangent squared x plus 1. Could I also write 1 plus tangent squared x? Would it matter? It wouldn't matter, right? So you know you can rearrange a plus. Can you make 2 more formulas? That's secant by itself. Could you get tangent by itself? What would tangent squared x be? Yes, it would. Now, could you get the 1 by itself? Could we put these 2 together like we had sine and cosine? What would we say? Secant squared x minus tangent squared x equals 1. Does that work too? Now, where did all these come from again? They all came from our main formula. And where did it come from? It's just the Pythagorean theorem. That's all you're doing. Hence, these are called the Pythagorean identities. All right, let's go back to the original. And we're going to write it again. And where did this come from again? What is sine squared x plus cosine squared x equal 1? The Pythagorean theorem. Where did this 1 come from? It's our hypotenuse back to our unit circle. We always say 1, right? Now what are we going to do? Divide by sine squared. Is it legal to take an equation and divide by something? Yes, as long as you what? Every term, right? Both sides. I like to think about every term. I think you're much safer when you divide to write it under everyone instead of just writing one big line. Now, what's sine over sine? Of course it is. What's cosine squared over sine squared? No, cotangent. 1 over sine squared? Yes. So now we know what cosecant equals, right? So I can say cosecant squared x equals 1 plus cotangent squared x. Now, can you rearrange this? Could you get cotangent by itself? What does cotangent squared x equal? Oh, what did I do? I'm talking and I wrote cosine instead of cosecant. There we go. What is cotangent equal to? Scoot the 1 over. What would it be? And then could you get them both on the same side? Cosecant squared x minus cotangent squared x equals 1. Now let me ask you an important question. If cosecant squared minus cotangent squared equals 1, what would cotangent squared x minus cosecant squared x equal? There we go. I want to point out that you could do that. Sometimes things are backwards, and I want to make sure that in math you guys realize if you have something backwards, like 5 minus x, and you want x minus 5, if it's a plus sign, you can just switch them, right? It doesn't matter. But if you've got something backwards from what you want, and you need to flip it, how do you do that? You do that by multiplying by -1, right? Or you could simply scooch people to the other side of the equal sign. But really, I just want to make sure that you know on all of these, you can switch them around if you needed a -1, right? Okay, so we got to have these memorized. Well, now you know I'm good at memorizing stuff. And right now I've written 10 equations down, and that's too much for me. I can't memorize 10 equations by tonight. So let's get it down to 3. Because if you knew the 3 major equations, could you always subtract something and move it to the other side without stressing? You could, right? Like if I gave you a test tomorrow, if you only had to know 3, you could then take each of those 3 and write all the other ones, right? So let's write down what we absolutely have to memorize. Sine squared x plus cosine squared x equals 1. What's the second one? Secant squared x minus tangent squared x equals 1. And what's our last one? So I've actually got this down to 2 because what do you notice, y'all? I want to teach you to memorize. Secant, tangent, cosecant, cotangent. Isn't that kind of like saying the same thing? So really, you got these 2. There's 1 plus, the other 2 are minus. To me, now you can memorize them in any which way you want. Pick out the guys you want. For my brain, the easiest way to memorize these was to do a plus minus minus. Sine and cosine just sounded normal. And then I'm like, I better get a secret tan, and then cosecant, cotangent. They went together. So if I gave you a test, if we were in the real world, I would give you a test. You would write those 3 down before you started your test, and then you would rearrange these to get your other 9 equations, right? Or your other 6. Does that make sense? Whichever way it is, you have to have these memorized. Okay, oops, sorry. You have to know those. I know we're in times where you get notes this year, but if you're planning to go on in math at all, you need to know those. Any questions? I know you don't have it memorized yet. Of course, that would be silly. But any questions over what we did? When it gets to the homework, you'll see what. Okay. I have bad news for you. We have to factor. And now all the factoring, I want you to think about this. Don't get scared yet. All the factoring you've done so far in your life, you're going to do again. Only instead of something saying x squared, it's going to say sine x squared. You're going to factor it with sine or cosine or tangent or cotangent or secant, which could be a little overwhelming, but remember, you already know all this. So let's look. That just looks bad, right? No, it's not. So let's look at this. If you were doing this problem, you see there's an x here and an x here, and there's a 6 in both, so you factor out the 6x, right? Now this time I'm going to say, look for words. Do you see a sign here and a sign here? If you see a sign in both places, factor out the sign. What about a difference of squares? If I gave you 16x squared minus 9, you'd say, oh, I got that. 4x squared, 4x plus 3, 4x minus 3. Now, isn't this a term squared and a term squared? Right? So instead of saying cosine squared x minus sine squared x, I could say cosine plus sine, cosine minus sine. Do you see how they parallel? I know that looks a little scary. We're going to do a bunch. Same thing with all of these. So my tip to you, my advice, is when you get a problem with all of these trig expressions, take out the word and do it with an X and just put the word back in. So let's look at this. How many of you already feel sick looking at that one? Come on, raise your hand. Somebody must feel sick. Okay. So instead of doing that problem right now, which is overwhelming because you've never seen that before, you're going to think this. You're going to think, oh, look, that's just x squared minus 5x minus 24. That's what you're going to think. You're just going to take the word out. As long as all the words are the same word. If they're different words, we're going to have to turn them into the same word, right? Now, how would you factor this? X minus 8, x plus 3. Did I do that right? It's early in the morning. Okay. Now, put sine back in. Put sine x back in for x. So everywhere you have an x, it's really a sine x. How's that? Not bad. We're going to be using these next block to solve equations because we're going to set them equal to something. Right? We're going to set them equal to something. And then you're going to solve them. And guess what the answers are going to be? 1/2 square root of 3 over 2. It's going to go back to your unit circle. So this weekend, make sure you know your unit circle. Put it back in your head because we're going to, not only are we going to factor, we're going to solve the trig equation. And then you're going to have to get the answer by going backwards to your unit circle and saying, oh, sine x is the square root of 3 over 2. Therefore, sine is pi over 3 or 2 pi over 3. Right? All right. What about this guy? What am I going to think on this one? What should I pretend that says for just a minute? There we go. That's better. Now, y'all factor that. I'll give you a second. Factor that. You can either group or you can guess and check. If any of you want help moving from grouping to guess and check, I'll work on some of those with you at the end. I won't make everybody do those. Not everybody likes that. Guess and check goes really fast, but you got to be really good with your arithmetic. See, I know I need to add 3. That's 4 and 1. See if you got what I got. Y'all group or factor that any way you can. Now, once we factor it the old-fashioned way, what are we going to do? What is our answer going to be? What? Tell me in words what we're going to do. Replace x with what? Sine x. So now, do you have to write it down this way? Is that a requirement? No. After you do a million of them, you won't have to go over here and think about that anymore. But in the beginning, this may look overwhelming. We'll just take that out and we'll be fine. All right, tell me what this guy is. What are you going to think on this one? Nine x squared minus y squared, right? We have to put 2 different letters because this is a sine and this is a cosine. So what is this pattern? What do you call that? 3 words. Yes, excellent work. That is a difference of squares. And we know the pattern for a difference of squares, 3x plus y, 3x minus y. So that's going to be what? 3 sine x plus cosine x. 3 sine x minus cosine x. Okay, what about this tangent guy? What can we do here? There's only two things, so it's not going to be a trinomial. What's our rule of thumb in math? What do we always try first with factoring? Greatest common factor, right? And especially if you see the word tangent, the same word twice, right? We know we could take out a tan. And then if you have 4 and 12, what can you factor out? The 4. So 4 tangent x. What goes in here? 4 tangent x times what will give me 4 tangent squared x? Tangent, right? Minus. Now 4 tan x times what gives me 12 tan x? 3. Tan times tan is tan squared. Yeah. They look funny. If this was scary, could you think this? Could you think that first? You could. As long as you need to do that, do that. You know, I find these easy, but I've done a million of them. This is your first day. It might be a little hard. Right? Now, if you have trouble factoring, just general factoring, this is going to be real hard. So if you need to brush up on your factoring, where can you do that? What am I to do as a student? Well, I can come in at lunch and ask my teacher. In today's world, I can also go home and I could just type into the Google factoring practice, and how many different ways to practice factoring will come up? A million, right? There's no reason to not be good at that. And I will help you. I can Zoom at lunch or I can be here at lunch. What now? What is the problem with this one? I'm scared. I'm going home. Well, what is that? It's a difference of what? Difference of cubes. What do we use for a difference of cubes? Is that too bright? Is that better? Okay. What do we use to solve a difference of cubes? We keep them clean. Clean cubes. What do we use? Soap, right? So I'm just going to pretend like now, like there's an X and a Y. If these have two different names, you got to give them two different letters if you're going to go try to do it without those. So let's do this without the scary letters, right? Let's do x cubed minus 8y cubed. How would you factor that? Well, it's a difference of cubes and you've got to recognize it. So same sign, opposite sign, always positive. Cube root of x cubed is x. Cube root of 8y cubed is what? 2y. And now I take these guys over. X I put here and square it. The 2y I put over here and square it. In the middle, I multiply those two guys together. You know, if you need to make this helpful tonight when you look over it by yourself, show yourself. There's my x's. I'm going to color those orange. Here's this. I'm going to color that green. And then maybe this one, I'll underline bold so I can see where they came from, right? Make your notes very helpful to you. Okay, so now what am I going to do? I'm going to replace x with what? Cosine x. And I'm going to replace y with what? Sine x. So let's do this. What is that first one going to say? Cosine x minus what? 2 sine x times. That's x squared. So what's it going to say? Cosine squared x. Now notice, okay, for trigonometry, if the whole thing is squared, the squared goes right here because it's cosine that's squared, not the x that's squared. It's cosine of x that's squared. And you need to notice that it's written right here. Plus 2. This says xy, so what will I write in there? Either way you write it, usually if you see two things written together, sine and cosine times each other, people, they'll always write sine first. Plus 4, y was sine, because I identified it here to make it easy on myself. You may have to go home and write that down a couple of times, right? Why are we doing this factoring? What comes next time? Equations. You're going to have this might be set equal to 0 or some other number. You're going to have to factor it and solve it just like you do in algebra. All right, what's this one? Y'all got that one. Maybe not. I'm going to write up here. How do we do this? X to the 4th minus y to the 4th. How do you factor that? What is this really? Either Kate or Hutton told us a minute ago. I can't remember who. Difference of squares, right? So this is a square, this is a square. So what is that? X squared minus y squared times x squared plus y squared, correct? Now, does this one factor again? It does, right? X plus y, x minus y. Does a sum of squares factor again? No. All right. So now instead of going crazy and getting all scared, I'm going to write myself a note. Replace. What am I going to replace with? X will become what? Sine x. And y will become cosine x, right? Sometimes it's easier to identify what needs to be in there so that by the end you're not like, oh, I quit. It's too late to quit now, right? So that's going to be sine x plus cosine x. Now remember, our trig functions had the same variable. We wrote different ones because sine and cosine are actually the variables, right? What else goes in here? This is going to be so cool. Wait till you see the end of this. Now, are we done? This is going to blow your mind. Are we done with this? Who knows something special I can do with that you just learned today? Come on now. Go back to your first page if you... Well, we don't have an equation yet, but I think I heard, yes. What is sine squared x plus cosine squared x? 1. So does it matter? And that leads us back to the importance of knowing all this. Do you see how you're going to have to recognize these things to work through? Having them on a list won't be enough because you'll just be searching lists on every problem. Excellent work. Okay, so my final answer then would just be that because this turned into 1. Isn't that cool? How a big scary thing, and I want you to keep that in mind as you go through these big scary equations are going to get smaller and turn into 1s or just a name. All right, what is this one? Come on, y'all can do that one without switching it. What is it? It's a difference of Write that down, difference of squares. And what's the pattern on a difference of squares? A plus and a minus, and they're the same. Square root of 1, square root of cosine squared. How you feeling? Okay, I'm going to give you 30 seconds, and you try to do that one. Go. People at home, do this with us. Are y'all having fun? Isn't this cool? Doesn't it make you feel smart that you can actually do these scary hard problems? Yeah. And if you can go further, feel free to try to finish these up. And then we're going to kind of start on the homework together. There's 2 little assignments tonight that are very short. One's in Class Kick, one's in Delta Math. And we're going to do the Class Kick one. We're going to get that started together so you see what this new monster looks like, okay? I think these are so fun. I love them. They're like little puzzles. Or it's almost Halloween. They're like unmasking this, who's inside there. Like when it's sine squared plus cosine squared, it's like he's in a mask. Who is he really? He's really just a 1. It's like taking off the mask, right? It is, that's perfect. A Scooby-Doo mystery. Hey, if you have to do something, you might as well make it fun. All right. What did y'all get for number 8? Cosine x minus 7. Very nice. Very nice. Okay, what about this guy? Now, what I want you to do is make sure that it's always the same word. And today I only gave you the same word. Later on, we'll practice some harder ones. If the words are mixed up, we've got to get the words to match before we can do a trinomial. All right, come on, y'all get this one done. If you need help on this one, think 12x squared minus x minus 6. Right? And if you need to, now I like to use guess and check, but if you need grouping, how does that work? We need them to add up to negative 72 or multiply to negative 72 and add up to negative 1. And what numbers are those? Negative 9 and 8. So we rewrite it, right? 12x squared minus 9x plus 8x minus 1. And then we group. I don't particularly like this method because it's long. I like to do the guess and check, but guess and check takes you practice. Now, what happens if you can't, wait, why did I write 1 down? That's a 6. Okay, so this is 4x minus 3 because those fellas match and I'm pulling it out, and 3x plus 2 is left. And what am I going to replace? Let's write down with words. So when you look at this in 3 days, you're not like, what did I do? Replace x with what? Right? And what does the word tangent mean? Slope. I just want to keep asking you that. It's so important for next year. Okay. All right, the last one. What do you notice here? The same word twice. So what are you going to do? What process should we use? Has 3 letters. GCF. Always GCF if you can. So I could take out secant x, and what's left inside? Now, what is this fellow's name? We just did one. Difference of what? Difference of cubes. So that's going to use SOAP. So we have secant x times what? SOAP, same, opposite, always positive. What's the cube root of secant cubed? Cube root of 1. Then we put them over there and square them. Then we put them in the middle. I wrote way too small. Can y'all even read that? You can't read that. I don't know what made me think I could fit it in a small space. Okay. That's the end. You ready to try some together? And see what would I do with these? Oh, did I close that too quick? There you go. This, right, was from our difference of cubes. So this part turned into this part, right? Highlight your notes. It really will pull your eye there, so later when you're looking at it, you're okay. All righty.